Joined online for today's webinar for the 17th talk under Users, Science and Our Life lecture series by Professor Pradip K.Tewari on water issues in rural areas, IIT Jodhpur interventions. This is Manushi Chakraborty welcoming you all on behalf of the Indian Women Scientists Association. May I briefly introduce you all to USA, especially for the benefit of the participants who have logged in for the first time for this activity. So, first slide please. Suparna. The sprawling complex that you see in the slide is the headquarters of the Indian Women Scientists Association at Vashi, Navi Mumbai. The picture on the left are from the recently added learning garden at the premises. Next slide, please. Next slide. Our association, that is USA, is journeying into the 49th year of its foundation. In 1972, 12 founder members who then represented a wide spectrum of scientific disciplines associated with different scientific institutions got together and decided to promote science in society and uplift the not-so-privileged class of the society and for women. Thanks to our founder members' efforts and far-sighted visions, that now USA has grown from its headquarters at Vashi to 11 branches across the country. USA's main mandates are developing scientific temper in our society, disseminating scientific knowledge through lectures, seminars, discussions, training, and workshops, promoting professional accomplishments, conducting research on women and child welfare. Next slide, please. Yeah. Since the pandemic started, we switched all our activities to the online mode and continue holding all our lectures virtually. The new lecture series initiated in 2020 are Member Enrichment Program, Science and Our Life series, Member Empowerment Program, and Wellness, Health and Happiness Program. The Member Enrichment Program completed after 40 webinars, but we will be back with another series of lectures, garden-based learning. Science and Our Life lecture series, one of which you are witnessing today, is being carried out by our Science Awareness Committee. Next slide. Our new collaborative program with Vigyan Prashar, initiated in 2021, are Each One Teach One and USA VIPNet Science Club. Next. Now coming to a little more about Science and Our Life lecture series. This lecture series tries to bring you speakers from all disciplines of science who can tell us about the science underlying in all the things that we always wanted to know. They help us understand the basic day-to-day phenomena which affect our lives. Topics on health, education, food, history, as well as the marvels of the myriad discoveries and inventions made by humans are being addressed in these lectures. Today is the 17th webinar of the series. We have already covered many important topics like How Do You Know What Lies Within by Padma Shri Professor Rohini Godbole, Healthy Habits for Bladder and Bowel by Dr. Niga Majahariharan, Application of Nuclear Radiation by Dr. Meera Venkatesh, and many more. So there has been a wide variance in the subjects covered, and what is highlighted is science behind the topic. Next slide, please. We request all women graduates to join us as members and help us in our efforts towards knowledge sharing, nurturing future leaders for science and technology, promoting innovation, and emphasizing science-based learning. Do read about our activities in our newsletter, which is published thrice in a month. As USA is a non-political, non-profit NGO, we welcome donation towards our various ventures. Lastly, USA will celebrate its Golden Jubilee in June 2022, and I urge you all to keep a watch for a variety of events. Now coming to our today's talk. Rural areas have insufficient access to potable water due to lack of sustainable development, along with many other issues. Today, we have with us Professor Pradip K.Tewari from IIT Jodhpur to give us an insight into these problems and remedial measures for the same. There is a small announcement here. Audience will be running a question and answer session at the end of the talk. So please post your queries in the chat box. It will be taken care by the speaker at the end of the talk. And please switch off your videos and mute yourself for the smooth transmission of the program. Now I would like to call Dr. Shamla Bharadwaj, Vice President of USA, to introduce our today's speaker today. Dr. Shamla Bharadwaj retired as head Fuel Cell Materials and Catalysis Section, Bhabha Atomic Research Center, Mumbai in December 2015 after 38 years of service at BARC. Her expertise is in the fields of chemical thermodynamics, catalysis, fuel cells, and hydrogen energy. As professor of HBNI and Mumbai University, she has guided several MSc and PhD students. Currently, she is Vice President of Indian Women Scientists Association and editor of USA newsletter. Over to you, Dr. Shamla.
Thank you, Manshi, for your introduction. And also it gives me, great pleasure to introduce my batchmate, Professor Pradip K.Tewari. He is currently the head of Department of Chemical Engineering at Indian Institute of Technology, Jodhpur, and he is a renowned expert in membrane technology and water solutions. And Professor Tiwari, he joined Bhabha Atomic Research Center in the year 1977 and after his graduation in chemical engineering. And then he received his PhD degree in chemical engineering from Indian Institute of Technology, Bombay in the year 1987. He has he rose to become the distinguished scientist in the year 2012 and associate director of chemical engineering group in BARC in the year 2014. He was consultant to the Office of Principal Scientific Advisor to the Government of India on water issues. He was a professor in Homi Bhabha National Institute for more than a decade. And Professor Tiwari has been a consultant and advisor on water-related issues to several government bodies and organizations, such as Department of Drinking Water and Sanitation, Department of Science and Technology, Defense Research Development Organization, Oil and Natural Gas Commission, Bureau of Indian Standards, Chennai Metro Water Supply and Sewage Board, and so many such bodies. He was chairman of International Nuclear Desalination Advisory Group and Technical Working Group of International Atomic Energy Agency from 2005 to 2015. Dr. Tiwari is fellow of Indian National Academy of Engineering. He is vice president of Asia Pacific Desalination Association. Professor Tiwari has more than 170 research publications in peer-reviewed journals, proceedings, books, encyclopedia, and so on. He has 2 patents to his credit, authored 2 books, Nanocomposite Membrane Technology, published by CRC Press, and Advanced Water Technologies, again by CRC Press, USA. He is a member of the editorial board of several peer-reviewed journals, such as Desalination and Water Treatment, and many others. He is recipient of several awards and he has received the Group Achievement Awards of DAE. With these words, I invite Professor Tewari to deliver his talk, which we are eagerly waiting for to listen to. Professor Tewari, please.
Thank you, Dr. Shamla. I will share my screen just. Just to confirm, can you see my screen? Slides?
Yes, Professor Tewari. Here, I'm able to see.
Yeah. Thank you. Thanks. Good afternoon, everyone. I just go to slide mode and yeah. Thank you and thanks to Indian Women Scientist Association for inviting me to discuss, to talk on water issues in rural areas, IIT Jodhpur interventions. On the eve of 75th Independence Day of our beloved country. So greetings from IIT Jodhpur also to all of you. I'm aware that each one of you, the association member, is a role model for many youngsters and others. I'm also aware that societal issues are very close to your heart, near and dear to you. My special thanks are to Dr. Shamla Bharadwaj, who is a friend, and also my batchmate. And she was topper of chemistry discipline in our batch. So she was also a role model for many of us. As I said, I'll talk on water issues in rural areas and particularly IIT Jodhpur interventions. You see the industrial revolution, and it was like industry 1.0 in 18th century when steam power came into picture, and we started shifting from the world started shifting from cottage industry to mechanical production. 19th century was for industry 2.0, electricity. And 20th century, mid-20th century was for electronics. Today we talk of industry 4.0. That's robotics, 3D printing, Internet of Things, artificial intelligence, big data. So earlier when industry product used to be of prime importance, industry 4.0, they are now multi-stakeholders, and society 5.0, which has already started coming and will take over the industry 4.0, that society will be the major stakeholders. During the industry revolution, it was like product is of more important, product was of more importance. Now and in time to come, society 5.0, society is of more importance. Societal issues will be of importance. And that's how you say in 2015 Sustainable Development Goals were decided by the United Nations, by all the member states, and this was the consensus. And now they have become the prime motivator for science and technology to develop further. And where clean water is one of the very important aspects being considered in the Sustainable Development Goals. Look at the water availability. Red mark shows the red and yellow, light yellow. They show you the water stress areas. Our country, India, in 1950s, it was water abundant region. What it means is the water availability was more than 5,000 cubic meter per person per year. Today, water availability has gone down to the level of less than 2,000 cubic meter per person per year. And when it goes down to less than 2,000 cubic meter per person per year, as per the acceptable data by the world community, that region is known as water stress region. So now we belong to water stress region. So water stress region is one thing. Also look at the map of the country. The red color shows where the withdrawal of groundwater is more than the available supply. The water table is going down and down. That's another major concern country is facing. That's why, as per United Nations, it is considered as water is considered as one of the top grand challenges, top 10 grand challenges. And our country, our population is about 16 to 18% of world population, but we have just 4% of the world water resources. That is the availability point of view. 16 to 18% of world population, only 4% of world water resources. And all the water available, there are also water quality issues. India, our country, has 7,000 to 8,000 kilometers long coastline, very long coastline. And fresh water availability in the coastal areas is a major issue. We are aware several of our rivers and water bodies are polluted. Groundwater in many villages, many places is contaminated. So issues or challenges in our country are quite unique and quite unique compared to rest of the world. We have water quantity issues, we have water quality issues. And this gives you the kind of contamination the groundwater has in our country. Some places are affected by fluoride contamination. And because of fluoride, there are kinds of diseases, first kind of diseases coming. The bone deformation takes place. There is places like arsenic contamination in the eastern part of the country. And now it is going to along the Ganges belt, including Bihar, Jharkhand, Uttar Pradesh, all that area. Salinity, Rajasthan, Tamil Nadu, Andhra Pradesh, many areas, Gujarat, they have the salinity issues. Iron contamination is one of the major issues in the hilly areas of our country, like Uttarakhand and other hilly areas, and multiple other contamination, bacteria, virus, microorganisms, several other contaminations are there. Rajasthan scenario, look at Rajasthan has more than 10% of the country's geographical area, but only 1% of water available in the country. So total scenario, if you look at, country has 4% of the world water availability. From the 4%, only 1% is available in Rajasthan. And there also in many places, there are contamination, water contamination of turbidity, color, fluoride, salinity, bacteria, virus. These are the contamination issues here. And Rajasthan is rich in culture. So there is a traditional small scale industries are here in rural areas. And they face the wastewater issues, the effluent issues. That is another issue which is contaminating the water further. Jal Jeevan Mission, our government is committed, and this is a big program government has taken up to provide functional household tap connection. Short form it is called as FHTC, to every rural household. It's Har Ghar Nal Se Jal at 55 liters per capita per day. And for that, this is to be done by 2024. Government has taken a decision that this will be completed by 2024. Very good initiative. And this covers the in-village water supply infrastructure for tap water connection. It includes reliable drinking water source, including development and augmentation. It also involves transfer of water in case quantity and quality, both are the issues. In case not enough water is available and quality also is an issue, then transfer the water from one place to other place, to the place where it is required. Technological intervention for treatment of water to make it potable. Retrofitting of completed and ongoing piped water supply schemes, which is going on. Grey water management, so that it can be reused or recycled. And capacity building of various stakeholders. This is a big government program, and this is already on and will be completed by, as per the target, 2024. So these are the challenges, and the water market, if you look at in our country, it's $15 billion water market, and growing at the rate of 18% per annum. Industrial water market is $3.5 billion, which is again going. Decentralized drinking water system, like popularly people know it as RO units, domestic RO units. That water market is of the order of $0.7 billion, and potential is quite high if you cover the other areas also, because it is currently being used by resource-rich users. But there are challenges. Challenges involved are Clean drinking water is needed by resource-rich users as well as resource-poor users. Everyone needs the clean drinking water. So the technology, one can say it is low cost. It is costing one of the minimum cost, lowest possible cost. But affordability issues come into picture for resource-poor users. Another issue is it is needed not only in the cities and townships, but also in the rural and remote areas, where the facilities available are not to the level of what is available in the cities. So there is need for requirement of simple and robust technology. And being a big country, our water issues are unique. Water issues in the country in different places are unique. In the arid, semi-arid regions, there are other kinds of water issues. In some other hilly area, the water issues are quite different. In the coastal area, water issues are of its kind. So indigenous development is required for us to handle our own problems. And it's not that one model existing elsewhere in the world, we can follow it. In our country, there is need for technology innovations that is simple, repairable by the local technician, local people, sustainable. And because of these challenges, the potential to impact the common man's life is yet to be explored, to be exploited. And these challenges are now because of the COVID-19 pandemic. The water requirement has gone up. You see the newspaper reports, and it comes like because now there is frequent regular intervals hand washing. There's frequent washing of floors in offices and in homes, in houses, in commonly used spaces. So this means additional per capita water requirement has gone up both in household, industries, hospitals, and many public areas. And because of use of the disinfectants, wastewater, there is additional load on the wastewater. And there are more challenges in the rural and remote areas. Water purification, when we talk of energy, is one of the important things because water purification process require energy. And when we require energy, this was discussed in the Paris Convention when the climate change was being discussed there. And during the discussion by the member states, it came out we are talking of reducing the carbon footprint in the environment, controlling the carbon footprint. But because of the water issues involved, there will be many water purification plants, many desalination plants in time to come. And they require energy. And that energy is from the fossil fuel. So one side we talk of reducing controlling the carbon footprint. Other side, because of this reason, carbon footprint will increase. And they worked out the details of this. And it was found that for the desalination unit, for producing 1 cubic meter of water, good quality water, if it is coal-based plants, if you are taking energy, electricity from the coal-based plants, you are emitting 3,600 grams of carbon dioxide. From oil producing plant, you emit 2,500 grams of carbon dioxide. Natural gas, we emit 1,500 grams of carbon dioxide. Similarly, nuclear, about 11 to 12 grams of carbon dioxide. Solar is zero, of course. Minimal, I'll say, solar, wind, renewable. So during the discussion, it also came out the pollution also is more in the existing coal technologies, also in the natural gas technologies, but solar and nuclear, they reduce, they have the potential to control the carbon emission. So there is need for the low carbon water purification units. Low carbon water purification units, what it means is either it should be based on that no energy required, that's the best kind of scenario, or least energy required, or reduce the energy requirement, that also helps the environment. So IIT Jodhpur has a strong group working in this direction, addressing the major issues in the rural and remote areas, addressing the issues of the carbon emission to the environment, water, both. And we had the researchers working from the computer science engineering, from the electrical engineering, chemical engineering is of course one of the very important department. Also from the mechanical engineering, bio, and several other departments, including the management also and humanities. And we are involved in the scientific social responsibility activities in the neighborhood, particularly in the rural and remote areas. We have also taken up one of the district as the aspirational district for water technologies and healthcare. We are also connected to the Unnat Bharat Abhiyan with respect to water technologies and agriculture. And through these programs, we are looking into the water technologies, propagation and deployment demonstration in different villages. And the adopted villages by IIT Jodhpur and the Unnat Bharat Abhiyan joint initiative are in Barmer, Bikaner, Churu, Ganganagar, Hanumangarh, Jaisalmer, Jhunjhunu, Jodhpur. So almost all the districts of the Rajasthan where suspended solids, fluoride, bacteria, virus, salinity, these are the major issues. And we normally use the membrane-assisted absorption-based processes. And when we talk of membrane, it's depending on the requirement. It's not that everywhere RO is used, no. We look into the kind of requirement. For example, microfiltration. It can remove the bacteria and suspended solids. So where the issues are bacteria suspended solids related, use only microfiltration. The energy required is minimal here and it does the job. The ultrafiltration technology, when the high molecular substances are present or the virus is present in the water or the turbidity is present, then ultrafiltration is right kind of technology. Energy requirement is much less in this, though it is more than microfiltration, but this can be used here. It also removes the color. Nanofiltration can remove the bivalent ions up to bivalent. So if the hardness is the issue, if the calcium, magnesium, or the organic substances are the issue, then we go for nanofiltration technology. And reverse osmosis only is to be used when the monovalent ions are to be removed. When salinity is because of the monovalent ions, then only RO is used, and the energy consumption in RO is very high compared to any of these processes. Also, the water wastage is quite high in RO compared to any of this process. In fact, the microfiltration, ultrafiltration wastage of water is almost nil. The energy required is almost very minimal. It can take it that it is almost tending towards a few meters of head of the water column. So we have used this kind of technologies, particularly the ultrafiltration technology in the schools in the rural areas, and this work is done during the COVID-19. So as you know, since last 2 years, we were facing the pandemic issues. And this is the time we utilize in the 1.5 year. We put up the water purification units in villages. Like the first one which you see, it is a government primary school, Jipasni village in Jodhpur. And these are the students. They participated in setting up the units, in installation of the unit. They can clean the unit. They can open the unit, and minor maintenance also they can carry out. We have trained them. This is government school, Rudia village. We have installed the units. We have also designed and developed the unit installed in the school of right side, which you see, and another school also. Those two further 2 schools we have installed the units. The methodology what we follow is that we involve our students from IIT Jodhpur. Like you see the photograph on the left side, the 2 students, that there is a group of 5 people standing there. One lady is a principal of the school, and 3 students are the basically from the IIT Jodhpur side. They are MTech or PhD students. The 2 students of the schools, they are 5th standard students. These people, and one is the staff of the school. These people have participated in installing the unit, in training the unit. The 2 boys, young boys whom you see, they participated in the unit installation. To start with, they wanted to see the unit, they wanted to open it. So the principal who is standing there, she told them not to touch the units. These are the, don't do this. Of course, she has her own reasons for that. But, we deal with the students in the rural areas, and also as per new education policy, now it has come. So this work was done much earlier corresponding to that. So we said these students, no, you open it up, open the unit, see the unit, and then they participated in the installation of the unit also. So that's the kind of participatory work we involve. And this gives the clean drinking water. There is no risk of waterborne diseases, it is minimized. And there is also capacity building takes place. We are now planning to install several such units in the next phase, and I'll come to that. So this local participation of teachers, because from the principal, we take an undertaking. It's not the MOU, not the memorandum of understanding, but it is letter of understanding that the unit what we are installing will be looked after by you, and it is like custodianship of the unit. So local participation of teachers during installation and students through the education in operation and maintenance. This helps in O&M by the local people only at the lowest appropriate level. and also the adequate capacity building. So this is a kind of Jan Andolan. We also provide the primary school students and introduce them to the practical aspects of education. Like, primary school students, they are not open to any practical work. So here then the student, they can come and see, they can operate the valves, they can open the unit, they can clean it, they can further put it back. And they also contact us in case something is required. So this will act as a nucleation to skill development at primary level itself. And now an integrated approach to dense decentralized community managed systems, the sustainable water management. So this is the Jal Shakti Abhiyan, we call it, and it's moving in this manner. What we do is that first we visit the site. Site visit is conducted. For example, this case is of Rudia Madhyamik Vidyalaya, shown here. Through the site visit, then we contact the school principal, and there is a school principal request for the requirement that is sought. If there is willingness is there, and there should be dire willingness for the water, then only we go ahead. And proper verification of the need is assessed by us. A customer, and assessed by us, when we say it's not me, it's my students, it's our student, they are involved in the job. A customized solution is researched. We design, develop the unit corresponding to that what is to be done, kind of taking into account minor local issues involved. And that is done within a month and implemented as shown in the right-hand side. So this implementation is done involving the students of the Madhyamik school as well as our students and the staff members. Now, for this kind of unit, water purification units, which is membrane-based absorption, membrane-assisted absorption-based units, it involves design, installation, testing, commissioning. And this, we have got CSR funding by one of the public sector company for installing such units in 25 schools in the rural areas of Jodhpur district. We have identified 35 schools. Out of 35 schools, 25 schools will be putting up and installing these units through the CSR funding. In the same direction, we have also developed gravity-based clay ceramic water filters. This is, we call it G filters. And here local materials are used in this unit. And this one we have set up, put up in different places in the villages. We train the potter. In this case, our student, we train the student first. Student, they go and they train the potters. You can see the left side, the down one. This is the potter, and there are visitors who are seeing how it is being done. So potters, they make it. This is the capacity building in the potters. And we provide them whatever clay you are using, you mix this much more clay of this standard. That formula is given by us, and the potters make it, and that is purchased by the villagers, and it adds to capacity building and resource building for the potters. Here also, for the to do it at the bigger scale, larger scale. So there is a Jodhpur industry connection we have taken, and molding machine is made by the local supplier. He makes the machine, and that is given to for the larger units in the villages, so that they can make more number of units through this. This program is now has been taken up in other states also, in Kerala, in Bihar, in Tamil Nadu, in Chhattisgarh, several other places also this is propagating, because our students who are doing this job involving in this, they were from different states. So they have taken it to their states, and some of them have already started this unit, manufacturing unit kind of thing, to supply to villagers using the local materials. The importance of this is this uses the local materials, and the formula is given by the institute. So these are different kinds of different arrangements of the G filters with several modifications and being used here. We have also in the Rajasthan places like Mount Abu. Now their water is one of the issue, but there is a lot of dew and humidity is quite high. So there we have set up the water catching units, dew catching units, and dew catching stills are put there, and that is able to collect smaller size to bigger size, and that collects the water and it is supplied to it is used by the people there or by the household there. This is another work we are doing, again based on the local material. So this is the subsurface porous vessel drainage management concept. So when the flooding takes place, it is possible to remove the excess water. And what we do here is the water from the surroundings moves to the porous vessel frustum. And that porous vessel is made by the Vindhyan era rocks and ceramic ware, locally available material in Rajasthan, and flooding water vanishes from the lode surface. Now this vessel, also we have introduced the kind of material in the vessel so that it purifies the water also. So the contaminated vessel, if there is possibility of contamination of the flooding water, that when passes through this vessel, that contamination, which is mainly of bacteriological origin, and the suspended solid turbidity, so that also is removed. So very simple system for the villagers. Grey water treatment unit. So this is another school where the issue was not only the water quality, also the water quantity was an issue. The water quality, we have put up a unit for the potable water, and that supplies them the right kind of water, purified water. Now, the primary schools in the villages, they are provided with the midday meal. So midday meal, the water which is washed, it is like grey water. So whether the grey water can be used for non-potable purposes. So that's what was the unit we have set up, did the experiment there and set up the unit in this scale. So grey water reuse, recycle and reuse in the schools. So this has brought down, the water scarcity which they were facing. So here, there are two kinds of units. One is from the groundwater, get the purified water for drinking purposes, for potable water. Other one is from the used water, grey water, get the water for the non-potable purposes, for recycle and reuse. So this is another kind of work. And this problem they face because of the COVID-19 scenario, because the water quantity requirement has increased. And this is, you can see the handwritten things. This is the kind of letter and agreement we have with the principal of the unit. Lady who is standing there with the red and yellow, she is the principal of the school. I tell you one of the important challenges in the rural schools. One of the school we visited, there were only one teacher. She was teacher cum principal in that school. There was one more employee. She was for midday meal cooking. So she was a cook. This school was from first standard to fifth standard, but only one classroom. First standard to fifth standard students were sitting in that one classroom, and these classes are going on. After midday meal, they have to walk to get the drinking water. So they are walking a distance, long distance to get the drinking water, drink it and come. This is the scenario in many schools. And at times, it becomes very challenging. But when you go and help them, when you go and work with them, the kind of satisfaction which is derived from this work, no one can replace it. And that's the kind of, in fact, principal, when we visited first time, she was scared and she thought we have come from the government side and maybe we are coming here for the survey and may punish her or things like that. But later on, she got the confidence, and that's how then she became very, not only very cooperative, she helped a lot. And with the students, the involvement, it has helped them. And she was praising a lot that the students are also quite disciplined and they are doing the job, they helped us. This is the installation work which is going on in one of the schools. These are the press release from the work what we have done and then what we are going to do in the 25 more schools. It was given wide publicity by the news reporters. Now, this is another issue because rural areas, as I said, Rajasthan is a culture rich place, and there are a lot many cottage industries also where handicraft and the local skill is available. For example, left side you see steel rolling mills. These steel rolling mills are very small. What they do is they get the steel plate SS202 category. That steel plate of 25 mm thickness, they cut it, they polish it to thin for making it utensil grade. And then they supply to different places. In fact, 60% of the utensil type of steel, it comes from the Jodhpur. Now, this steel rolling mill, they have about 100 numbers in one place, and they are doing this job. Very small industries. The effluent is water is generated, and that is acidic in nature. Right hand side, you see it is textile mills. Very small scale industry. Again, this is not like big textile mills. What they do is they get the raw textile cloth from the Bhiwandi area near to Maharashtra only, in Maharashtra, near to Mumbai only. From Bhiwandi, they get the textile. They do the dye here. This dye is corresponding to typical Rajasthani style, the printing. And then they sell it. These are 250 industries. They generate alkaline wastewater. Now, this acidic and alkaline wastewater, earlier there was no treatment. Now they have set up a kind of trust, Pradushan Nivaran Trust by the industries only. Now, effluent treatment, there are several challenges involved. So here again we are helping them because they are doing acidic treatment separately, alkaline treatment separately of the wastewater. So they contacted us and we are in touch with them. And this is another area we are helping them so that because Green Tribunal, the case has gone from the public side, and Green Tribunal has given them ultimatum that if you continue like this, generating wastewater like this, the industries will be closed down. So this is another kind of issue IIT Jodhpur is looking into. Again, this is in the rural areas, not in the cities. So when the water quantity and quality is an issue, there are rural areas which are like resource poor. There are also rural areas in the country that are resource rich also. Uh, we have found that there is need where quantity and quality is an issue. And like we have shown also, the different kinds of water, there's black water, there's gray water, there's groundwater, there's water supply coming from one place. Now, you need water for potable purposes, drinking water. You need water for the non-potable purposes. For drinking and cooking purpose, water requirement is much less. For non-potable purposes, water requirement is quite high. So look into depending on end use, give only that kind of minimum treatment and use it. So this can be done in a manner by providing minimum treatment, maximum use and reuse, and AIoT will play a very important role. AIoT will play an important role because of government scheme is also there for piped water supply. So through AIoT, you can find out if there's any leakage taking place. You can also find out whether the quality is okay or not. And this data can be seen by n number of agencies or authorized agencies. The water can be non-potable water can be used for the industrial purposes or for cleaning, even for the irrigation purpose also, giving only that kind of treatment. The requirement here is, and this is the challenge, the sensors. The sensors are required, the point of use sensors. The sensors are required which can immediately give you the quality of the water. And that is one of the challenging. It is available for pH, it is available for total dissolved solids, TDS, but there is need for measuring the bacteriological content. There is need for the other constituents also. So there is work going on in this direction, which will play an important role in time to come. So there are opportunities, many opportunities for the academia, from the scientific community side, like development of hybrid systems, development of new generation material, whether their life can be long. For example, membrane, like you get the membrane in the house, RO, they give 1 year warranty for the membrane. Normally in the industry, 3 years warranty is given. Can the membrane be available? Can we develop the membrane which is 10 years life? This will change the whole scenario of the water purification. Similarly, hybrid energy. No one was talking of the hybrid energy utilization. Wherever possible, if the hybrid, for example, Rajasthan area, the solar energy is abundant. So we have gone in a big way in the solar energy side. Similarly, there are several hybrid energy concept is possible, which may lead to a lot of reduction in the carbon footprint, at least controlling the carbon footprint. Innovative processes, spent membrane management is another area where work is required to be done, because these membranes, how to dispose them of, what to do with the membrane when they will come out, because water purification units are coming up in a big way. In different desalination units are coming in a big way. So spent membrane management is another area where there is a lot of work is required to be done. And recovery of valuable materials from the effluent streams. If we can recover the valuable materials from the effluent stream, because product also goes along with the effluent stream. If that product can be removed, can be recovered from the effluent stream, it makes a lot of sense. If water can be recycled and reused, it makes a lot of sense to the industries. Then it is possible the effluent treatment, instead of, it is a government-driven process. It is possible to make it industry-driven process because the owner himself would like to treat the effluent to recover the valuables. So there is a need for appropriate selection of technology also. And there the important thing is not only technology readiness level, also the impact factor, impact of the technology on the masses. Higher the impact, higher the technology readiness level, that becomes the most preferred technology. So this is important thing. Impact factor is normally not being considered, which must be considered in the technology development stage and technology readiness level, and local conditions. And one has to be vocal for local, be global. So be, vocal for local, thinking of the global, that's very important. Use the local conditions, local materials, and suggest the solutions for the local conditions, because water issues are quite different from one place to another place. So this is important. Technology selection is very important. Need not that we should use only one kind of technology everywhere. No, it's the appropriate technology selection is utmost important, and involvement of all the stakeholders, not only industry, also the user community, also the public, also the R&D academicians. The involvement of all the stakeholders is very important, and that is being followed through the industry 4.0 and society 5.0. The society, the stakeholders will become the major stakeholders, and multidisciplinary approach. Like I said, when we talk of the water systems now, there is not only chemical engineering, there is involvement of AI professionals, IoT professionals, electrical, computer science engineering, bio professionals. It is a multidisciplinary approach only can bring the real solution. I would also like to talk only 2 slides now on the Ayurveda. This work we have started in IIT Jodhpur, the hybridization of our ancient knowledge with our knowledge, present day knowledge. This is, thousands of years back, 800 BC, Acharya Sushrut. And Acharya Sushrut has given a clear mention that regarding the contamination of water. He also mentioned that water which is clean, which quenches thirst, which is cold, light, that is the best qualities in water. So he has given in the Sushruta Samhita and Sutra Sthan, he has clearly mentioned there that man who bathes immersing in rainwater, which has been contaminated, presence of insects, excreta over dead bodies of animals, having great accumulation of grasses and leaves containing poisonous substances, or who drinks fresh rainwater. This is all, he says, it is contaminated and it may lead to external or internal diseases. He writes like, Trinparnot karyutam kalusham visayutam yoga het varsasu pibedapi navam jalam sabrayam byantaran yogan prapuyat chipramevatu. This is Sushruta Sangita, Sutra 45/10. Similarly, he goes further and mentions that Dhavatva Karnasan Paribhadran Sapatlan Siddhak Mokchkocha Dagdva Saraj Drum Swam Valkamast Jasma Pitam Vitret Sarahsu Bhasmanjali Cha Api Gate Nidhaya Vishodhyedi Deepsit Meva Mamba. So this is again from the Sangita. He further comes out and he says, if you make the ash from the Dhav, Ashwakarna, Asana, Paribhadra, Patla, Siddhaka, Mokshika, Somvalka, should be burnt and ash is spread on the lakes. That can purify it. Even handful of ash you can add in pot of the water, and this can purify the water. What we are doing is we are doing experiments with our kind of adsorbents what we have developed. And we are mixing with not all the 10 what he says. We do with one and different combination and look into the impact and effect. We are also doing like Ayurveda method what is suggested. Uh, this is a reaction is quite slow. These are the slow processes. So by hybridization, we are trying to make it faster. So that will make a lot of value to it. The work is going on, and let us see how much we come up. The advantage with Ayurveda is they are eco-friendly, and that will add a lot of value from that point of view. So with this, I will if this is coming, I'll just see this is one. Yeah, this short video, if that comes, only 1 minute video. I don't know if it'll get connected. I think it is coming.
So we can't hear
Yeah?
the video, we can't hear.
Okay, so I'll stop this then. Sure.
We can read some what is there in the news below. That's all. Yeah.
Okay. So I'll stop sharing now. If there are any questions, I'll be happy to answer that. Thank you.
Thank you, sir, for sharing your knowledge with us. We all know how important water is for all of us. In spite of so much available water, most of it is not potable, especially in rural areas.